microfluidic model porous media or micromodel are a type of devices with a transparent connected porous network that enables us to directly visualize the complex fluid flow dynamics occurring inside. So first of all, it's a model system to model porous media. And we know that porous media, I think it's in, porous media is actually, well, ubiquitous in both engineering industry and even our daily life. Well, some larger scale examples include the oil reservoir. So we know that in the oil reservoir, which is actually a porous rock, the crude oil is flowing inside, and in order to get this oil out, people inject a water-based driving fluid into the porous oil reservoir and to keep the high pressure there and to push the crude oil out. So during the oil recovery process, actually at least the two different phases, two fluids co-flow in the porous oil reservoir. And also we have subsurface water flow in the soil. We have in the fuel cells, we have gas or aqueous vanadium redox species flow through the porous electrodes. And even in biology, our biological tissues can be regarded as a soft porous material as well. And we have the interstitial flow in the biological tissues. The interstitial flow is just a very slow flow fluid flux occurring in the extracellular matrix because of and this flow is because of the pressure difference between the blood vessels and the lymphatic vessels. So usually the pressure in blood vessels is higher than the lymphatic vessels. So this pressure difference drives the body fluid flow in the extracellular matrix, which is a porous medium. So we have porous media, and some other examples include like even the textile, the cloth is always porous, and like we have not only tissues in our body, but fruits or even in some food product, they are all porous, and we can have transport phenomena of, for example, fluid flow in those porous fruit or vegetables or food structure. So we have porous media everywhere. And in these porous media, we almost always have transport of fluid or transport of solute, mass transport or fluid transport. So in order to study these processes, preferentially we hope to visualize the fluid flow. We hope to visualize them directly. But these porous media, the real systems are always not transparent, always opaque. So how to visualize the fluid flow inside? And that's why people develop the transparent model porous media system so that we can directly visualize the fluid flow structure inside. So again, just the same as any microfluidic system, the interfacial force plays a dominant role in governing the fluid flow physics. Okay, so here there's a system showing a model porous media experiments using micromodel and microscopy in the Pacific Northwest National Laboratory. This is a setup in a real setup there. So the micromodel itself is very small. It's just a regular microfluidic device, and could be even smaller than that, which is on the microscope stage. And you have the microscope connecting to the computer so you can visualize it. This is a typical experimental setup. And before we really go to introducing micro model and how to use it under microscope, I also want to mention that micro model is not the only way to investigate fluid flow process in porous media. And for example, in the oil industry, people have been using X-ray microcomputed tomography or micro CT and magnetic resonance to study the porous structure. So people may just get a rock from the oil reservoir directly from underground and cut it into like proper size and use micro CT or magnetic resonance to visualize the 3D porous structure inside. The problem with these two techniques are their either low temporal resolution or low spatial resolution. For micro CT, it requires long scanning time. So even for a very, depending on the resolution you need, the higher resolution, the longer scanning time. So if you want to visualize, get the 3D structure of a real rock from the oil reservoir, which has the pore size on a few micron or even smaller, then a micro CT scan of a very small sample, like centimeter, like a few centimeters large, would take, well, at 1 micron resolution will take definitely more than 10 hours if you want really get high resolution. So it needs long scanning time, which means that you cannot catch the flow dynamics inside, because the fluid flow that time scale definitely much shorter than the scanning time. So we cannot study the dynamics using micro CT. And magnetic resonance can, well, scan faster. It can use to study dynamics, but the spatial resolution is very limited. So there are some disadvantages with both techniques, and that's what a micro model is supposed to address. So yeah, I also want to introduce a little bit about the micro CT. This is, again, even micro model is becoming more and more popular. Micro CT is still widely used because it can be used to visualize real porous media samples instead of the model porous media samples. So micro CT, well, I think I will first play this video, which is a great introduction about this technique. Then we can take a look at a few real experiments, images from my own experiment. Let me see if I can. Okay. It looks like frozen. Let me restart this PowerPoint again. It's not responding.